This is the raw data that the camera actually sees, and this is what the image looks like after reconstruction. So this is a computational imaging system. Instead of a lens, it uses a diffuser, and when you're using a lens, every single point in your scene maps onto a single point on your sensor, so it's really, really simple. You don't have to do any computation. But when you're using a diffuser, every single point, like this single point source right here, maps into an entire caustic pattern on the sensor. A single point creates this kind of image, but if you have an actual scene in front of your camera, you're going to have a ton of points, and so you end up with a bunch of these layered on top of each other in slightly different positions, which just gives you, a random blur. Actually get the image out of this by deconvolving the raw data with the point spread function that you get from capturing a single point, which is done with this pinhole aperture right here. And so you might be thinking, that's great, but this image looks pretty bad. What is the actual use of this? Well, theoretically, because this point spread function changes with depth as well as translation, you actually get 3D information encoded in all the caustic patterns created by every single point in your scene. And with the right calibration, you can take a 3D image using a single snapshot. None of this is new information. It's all based on papers and tutorials published by the Laura Waller Lab at UC Berkeley. So I highly recommend that you check that stuff out and make it yourself. Yep, that's it. Little side note, this comes from deconvolving the point spread function with itself to recover the original pinhole aperture. So yeah, that's what that is.